So today we're going to begin solving radical equations. Alright? And when we solve radical equations, there are 4 steps that we're going to follow. Okay? So here are the 4 steps. So if you are watching this video, go ahead and pause the video and copy down these 4 steps. Alright? Okay, so the first step is to isolate the radical. The second step is to raise each side of the equation to the same exponent to eliminate the radical. The third step is to solve the resulting equation using previous techniques. And the fourth step is to check the answers. Okay? So now I'm going to move on. If you have not copied down, go ahead and pause the video. Alright. So I'm going to work a few examples. Alright. And right now those steps might not make much sense. But as I work these examples, I will refer to what step that we're currently in. Alright. The first equation that we're going to look at today is 2 times the square root of x plus 2 equals 8. Alright, so if we're looking at our steps, our first step is to isolate the radical. So we're going to treat the radical like we would x. So when we isolate x, we want to get x by itself. So you have to ask ourselves, in step 1, is this radical isolated? Alright, the answer is no. We have a 2 in front. This is 2 times the square root of x plus 2. So to isolate this radical, we have to do the opposite operation. So we have to divide by 2. Since we're multiplying by 2 here, we will divide by 2 on both sides. So now we have the square root x plus 2, and 8 divided by 2 is 4. Okay? So step 1 says to isolate the radical. Well, now that radical is isolated. So step 2 says raise each side of the equation to the same exponent to eliminate the radical. So all step 2 is really wanting us to do is eliminate the radical. Okay? Up here we had 2 times the exponent. 2 times the radical. Well, to eliminate the 2, we did the opposite operation. Well, with the radical, we're going to do the same thing. If we want to get rid of the radical, we're going to do the opposite operation. Okay? So this is the square root, alright, or root 2. Well, the opposite operation of a root is a power. Okay? So the opposite operation of taking the root is taking something to the power. So instead of, just like the opposite operation of adding is subtracting, and the opposite operation of multiplying is dividing. Well, the opposite operation of taking the root is taking it to the power. So this is root 2. So to get rid of this radical, we're going to take it to the power of 2. Okay? And we're going to do that to both sides. That's what step 2 means. Raise each side to the equation to the same exponent to eliminate the radical. So when we raise the square root, so when we square the square root, we're just left with what's underneath. We're left with x plus 2. Okay? And on the right side we have 4 times 4, which is 16. Okay? So these are opposite operations. So the opposite operation of a power is a root. The opposite operation of a root is a power. So we do that in order to eliminate the radical. Now we're on step 3. We have eliminated the radical. So now we just want to solve the remaining equation. Okay? So to solve this is just something we know already. It's easy cheesy. All we have to do is isolate x. So we subtract 2 from both sides. Okay? When we subtract 2 from both sides, we're left with x equals 14. Now, before we say this is our answer, we have to do step 4, which is check. Okay? So we have to check the answers that we get. So if we plug in 14 to the original, alright, ignore Ignore the when we divided by 2, because the original is right here. Okay, so we plug in 14. 14 plus 2 is 16. The square root of 16 is 4. 2 times 4 is 8. 8 equals 8. So this is a solution. This works. Okay. Alright, now for another example. If we have the cubed root 2x minus 5 minus 2 equals 3. Okay. This minus 2 is not underneath the radical. Okay. And we're asked to solve this equation. We want to start with step 1. So we want to isolate the radical. Is the radical isolated? No, it is not. It's not isolated because this negative 2 or this minus 2 is on the same side. Okay? So we just want the radical by itself on either side. So it's on this side, so let's just get it by itself here. So to get the radical by itself, to isolate it, let's add 2 to both sides. Now we have the cubed root of 2x minus 5 equals 5. Negative 2 plus 2 is 0. 3 plus 2 is 5. So now we ask ourselves, is the radical isolated? The answer is yes. So now that it's isolated, we can move to step 2. And we can get rid of the radical. Okay? To get rid of the radical, we have to do the opposite operation. So this right here is the cubed root. Okay, we know the opposite operation of a root, or taking the root, is taking something to a power. Okay, so we want to take this right here, we want to cube it. We want to take it to a third power. Okay, the third power will get rid of root 3. Okay. So now we're left with whatever was underneath, which was 2x minus 5. We have to be sure to take the right side to the third power as well. What we do on one side, what we do to one side, we have to do to the other. And 5 times 5 times 5 is 125. And now we have eliminated the radical, so we're left with a linear equation. This is something that we can solve. So we're at step 3 now. Okay. So we just want to get x by itself. So we add 5 to both sides. We have 2x equals 130. We have 2 times x, so we do the opposite. So we divide by 2. So we have x equals 65. Now before we say this is our answer, we have to check it. So up here, if we plug in 65, okay, 2 times 65, that's 130. 130 minus 5 is 125. The cubed root of 125, we already know that from here, is 5. So 5 minus 2 is 3, and 3 equals 3. So yes, this is a solution. And we know it's a solution because this up here is a true statement. This side equals that side. Whenever this side does not equal that side, then it is not a solution. Okay. Now the last example I'm going to show you guys, it's going to be a little bit different. It's going to be the same at first, but it's going to end up being a little bit different. Is the square root of 2x plus 30, and that will equal x plus 3. Okay? So we have this. The first thing we want to ask ourselves, we're going to go to step 1, we're going to ask ourselves, is that radical isolated? Okay? Yes, the radical is by itself, alright? So it's isolated. So step 1, we don't have to do anything. We already have a check by it. It's done. So now step 2, we wanted to get rid of the radical. Okay? This is the square root. So we know to get rid of the square root, we have to take this to the power of 2 because it's the opposite operation. Okay? Taking something to the power is the opposite operation is taking the root. So these will end up canceling each other out. Okay? We got what we do to one side, we have to do to the other. So this is x plus 3 squared. On the right side, we have to square both sides. So when we square this left side, these cancel out. So we have 2x plus 30 equals, and then this right here, many people today, they have been wanting to distribute this too. They have been wanting to say x squared plus 9. Well, that does not work because this is not the product property. X and 3 aren't being multiplied together, so we cannot distribute this 2. Instead, x and 3, it's the sum of x and 3. And because it's the sum of x and 3, this squared terms means this times this. So this times itself. So like before, what we've seen already, we've seen this before, I believe it was last week. X plus 3 squared is x plus 3 times x plus 3. Okay? So now we have to multiply these two binomials. We have to distribute every term. Okay? So this x will go to both. Okay? And this 3 be multiplied to both. So 2x plus 30 stays here. Okay? Now x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. Okay. Now we just want to combine like terms. So we have 2x plus 30 equals x squared plus 6x plus 9. Now, compared to the previous problems, this one's a little bit different. Before we just had x. Once we got rid of the radical and we began step 3, which is to solve the equation, we just had an x. So we just isolated x. Well, this is different now. We have an x squared term. Hold on. Okay, so this one's a little bit different. Since we have an x squared term and x, we're going to have to handle it a little bit differently. We're going to have to get everything on one side. We're going to have to set all of this equal to 0. We can't just isolate x right away. We're going to have to set all this equal to 0 first. So I want to keep this x squared term positive. So I'm going to subtract 2x and 30 from the left side. Okay, so you get minus 2x minus 30 also on the right side. What you do to one side, you have to do to the other. So left side now, it's just 0. These all cancel. Then we have x squared, a 6x, and a minus 2x, which is 4x, and a positive 9, and a minus 30, which is negative 21. So now this is when everything that we've been covering the past couple weeks all comes together. So we have 0 equals, and we have 3 terms here. This is a trinomial. Okay? Trinomial. We know that we can solve this. This is a polynomial. We can solve this polynomial equation by factoring. Okay? And we know how to solve a trinomial. We can use the AC method. Okay? The AC method. Alright? Now, your A is 1, so since our A is positive 1, we can use a shortcut. And your A is 1 and your C is negative 21. So 1 times negative 21 is negative 21. So we're going to factor this now. Okay? Because we have all of our terms equal to 0, we want to factor. So our B here is positive 4. So what two terms here, or what are two factors that multiply to give us negative 21 but add to give us 4, or combine to give us 4? Okay, if we figure it out, it will end up being 7 and negative 3. positive 7 and negative 3, multiply to give me 21, but combine to give me 4. So this is what we want to use here. Okay, like I said, we could use the shortcut because our leading coefficient is positive 1. So this is 0 equals x plus 7 and x minus 3. Now if you forgot how to do this, this is something that you can watch on one of the factoring videos. Okay, so I'm going to zoom out just a little bit to give myself a little more room. Okay, so now we have 0 equals a factor times a factor. Okay, and we know we can get 0 through multiplication when we multiply by 0. So either this one or this one can be 0 to give us 0. It could be this times 0 will equal 0, or this times 0 will equal 0. So what we're going to do is we're going to set both equal 0. Whenever we completely factor a polynomial and we have it set equal 0, we can set each piece equal to 0. So this is x plus 7 equal to 0 and x minus 3 equal to 0. And now we just solve for x. Okay, solve for x. So subtract 7 from both sides here, so we get x equals negative 7. And here add 3 to both sides. So here we get x equals 3. And now we have to check. Alright, now we have to check. We want to check the original problem. Alright, so if we plug in negative 7 up here, 2 times negative 7 is negative 14. Negative 14 plus 30, that's 16. Now if we take the square root of 16, that is 4. So this side here, when we plug in negative 7, is 4. And then negative 7 plus 3, that's negative 4. Well, 4 does not equal negative 4. Negative 4 does not equal 4. So this right here is not a solution. Okay, so we can exit out. This right here is not a solution. Negative 7 does not work because this side does not equal this side when you plug in negative 7. So now let's try 3. 2 times 3 is 6. 6 plus 30 is 36. The square root of 36 is 6. And 3 plus 3 is 6. So this side is 6, that side is 6. Well, 6 equals 6. So this here is the solution. Okay? And that's how you solve radical equations. Alright? So important thing is, so we always have to isolate it first. Okay, that's step 1. Step 2 is once we isolate it, we want to get rid of the radical, and we do that by doing the opposite operation. So whatever the root is, we want to take it to that power. So this is root 2, so we want to take it to the power of 2. And once we get rid of that radical, we want to solve the resulting equation. Okay, we want to solve the equation that's left. Once we do that, we plug in our answers and we find which one works. Okay, hope you guys have a good day. Bye.